Alright, so moving on along, this time we've got a few definitions, and our definitions are nominal, ordinal, and cardinal. And so in these problems, I'm going to give you a number, and I'm going to ask you what type it is. So a nominal number is like a student ID, a checking account, a social security number, a telephone number. For example, my telephone number here at work is 562-3307. Now, that's not a counting number, meaning my number's not bigger than Miss Hale's number, or my number's not smaller. It shows no ordering. It's just a number that is identifying a certain phone line, right? And so there's not a place in that. 3307 doesn't mean I'm more than the next room or so forth. That's just an identification. Now, order, you want to think of ordinal. So if we have like third base, second place, that type of thing. Or let's see what else I've got in there in my notes real fast. This is the third room on the left, that type of thing. That's ordinal. Now cardinal, I ask cardinal on test all the time, and it's the easiest one, but my students miss it just because they forget by the time the big test rolls around. But cardinal, all that means is the number of items in the set. For example, if I took the vowels, a set of vowels, A, E, I, O, U, there are 5 elements in that set. So the cardinality is 5. It answers how many. Now in our previous video, we did this problem here with the intersection. And so if I asked you this particular problem right here, let's change colors. The cardinality, or you can say the cardinal number here, is 3. And it's 3 because there are 3 elements in the set. So the cardinal number tells you how many elements are in the set. Right? It's a funny S. So, for example, if Max placed 9th in the race, that was an order, and so this would be an ordinal number. If the assignment is on page 21, well, 21 is more than 20, right? It's an ordinal. It's a place in the book. So this is also an ordinal one. Now the passcode is 2417. Okay, that's going to be nominal, because one passcode's not bigger than the other. It doesn't tell you where the passcode lies in the scheme of things, right? It's just a name, or in that case, a way to get in. It's not bigger than the next passcode. It's just a number. And so that's what we have there. Okay, the next one is one-to-one correspondence. A one-to-one correspondence assigns each element of A exactly one element of B. Now I think of this in basketball if you have one-on-one coverage, or in football where you have one-on-one coverage. For every offensive player, there's a defensive player that matches up, and vice versa. So if I give you these two sets, we'll do the one above the bar. This one has 4 elements, and this one has 3 elements. So those could not match up in a one-to-one relationship because something's left out, right? You can't match 4 to 3 and have everybody have a partner. So this is not one-to-one. Okay, but looking at the bottom set, we'll color it pink. We're going to know which one I'm referring to. Looking at the bottom set, you have 4 elements in A and 4 elements in B. And so you could set up a one-to-one relationship here if you had A, B, C, and D. And they could correspond to 1, 2, 3, and 4. You could set up a one-to-one relationship there. So this one, yes, could be a one-to-one correspondence. Okay, and then it talks about the whole numbers. So you've got the whole numbers, the natural numbers, the counting numbers, and of course the main thing to know about whole numbers is whole numbers, natural numbers, counting numbers. They're not fractions. Okay, so that's the main thing in that set to pay attention to. Okay, the last thing in this set would be Venn diagrams. And that is the hardest part of the set. Okay, obviously I have sets on the brain. I mean section. So the hardest part of this section is going to be the Venn diagrams. And so we are going to make them into sets. You have two different types of Venn diagrams. You have one that has 2 circles and another group that has 3 circles. And so I'm going to go ahead and do the 2 circles on this video. So you have Mrs. Smith's class of 30 students, and they are conducting a survey. And in this survey, they have 2 different types. They have cat and dog. Okay? So when you work this one, you're going to have 1 circle for cat and 1 circle for dog. It doesn't matter which one goes where. I'll just label mine dog and cats. Now, we talked about the universal set earlier. That's how many are total in there. So the universal set for this one is 30. There are 30 total students. And so that's going to be an important part of this. Now, there's no certain way to start these, but what I have found when I work them is to start in the middle. So in the middle is where they overlap. So like this little place right here, that's where you have both dog and cat. So if you read through and start at the back and go forwards, it says 5 students own both a cat and a dog. Okay, so that's where I would start. Now go backwards from that. 15 own a dog. Okay, so here's my dog circle right here. This orange circle is my dog circle. And in this circle, I have to have 15 people. Well, right now I have 5 already. So to make 15, I'm going to need 10 more to go right here. 10 plus 5 would give me 15. So now I have 15 in my dog circle. Okay? Now, let's talk about the cat circle. I have 8 in the cat circle, so I'm going to color this cat circle green. In this green circle, totally, I have to have 8 students. Right now in the green part, now, we're not looking at this number at all, just the green part. In the green part, I have to have 8. Right now I have 5. I need 3 more to make 8. Okay, so that's how that part would look. Now, the other thing I always like to do is see, obviously that's not a total of 30 students, so there are going to be some people out to the side. We'll put them in this gray cloud over here that don't like animals. Okay, so this would be no animals at all, because everybody doesn't have one, right? So if you look in the circle, you have 10 and 5 and 3. Those students are accounted for. So 10 plus 5 plus 3 would be 18. So there are 18 students that reported that they did have an animal, but there are 30 people in the class total. So if you see how many are left and you take 30 minus 18, you're going to get 12. So there's 12 students that don't like animals at all, or whose parents said they couldn't have an animal, right? So now then, we have the total Venn diagram laid out. We have to answer the question. I don't like where I put this. So the question in the problem says, how many students own no dogs? Okay. Okay, here's my dog. Let's color it black, just for sake of reference. Okay, all of these people in this black and orange circle like dogs. So that's 15. So this group likes dogs and this group like dogs. Okay? So that, remember, I'm looking for how many have no dogs. Okay, so this 3 right here, they only have cats. They're not in the dog circle at all. So I have 3 that only have cats, and I have 12 that have no animals at all. So that would be 15 people in the class do not have a dog. And that's how we would do that one. Okay, so let's do one more of those 2-level Venn diagrams, and then we'll break this video up. Okay, so this time we have jelly beans, and we have red jelly beans. Let's just do regular for now. And green jelly beans. Not a beautiful circle, but it'll do the trick. Our total students surveyed for this particular one would be 50. We had 50 students surveyed. Okay, the easiest way to start, remember, is to start at the end where they both like, and that is always at the end. 17 like both red and green. Okay, shouldn't have used green. There we go. 17 like both red and green. So I'm going to have 17 right there in the overlapping part. Okay, so let's go to green, working backwards. Here's my green circle. In the green, it says 29 like green. So in this green circle, I have to have 29. Well, right now I have 17. So to see how many is left, we'll just subtract it. So there are going to be 12 of those that are left. Okay, here's my red circle. In the red circle, they have 30 jelly beans. Well, there's 17 that are already in the red circle. So that's going to be 13. So that's how my diagrams look. But I also have, remember, 50 total, and I need to see how many are left in the no jelly bean part. Well, I have 13 and 17 and 12 in my circles. If I add those up, that's 10, 11, 12, carry. 1, 2, 3, 4. 42 students are accounted for in the circles. But I have 50. So that means I'm going to have 8 that don't like jelly beans. Okay, I'm one of those 8. I don't like jelly beans. Now the question says, how many students like no green jelly beans? Well, I know there's 8 of them that don't like any jelly beans, so they don't like green ones. Now, looking at my diagram over here, all of these kiddos here in this green one, they all like green. 17 plus 12 like green. But this 13 right here, they only like red. So this 13 right here, they do not like green. So if we add them up, we'd have 21 that do not like green jelly beans. 13 like only red and 8 like none. So adding them up, that's how we'd get our answer.